Friends, welcome to Chemical Enlightenment. So today we will discuss about some of the point groups and rules of the point groups and how to identify the point group easily within the seconds. Okay, let us talk about some of the rules of the point group. So if we know the rules, then it is easy to identify the point group of that molecule. Okay, let us discuss some. So first will be the principal axis. So this is the main axis which is there called C and D. This is the principal axis, and second will be the subsidiary axis, and uh, there will be two mirrors called as horizontal mirror, and there will be vertical mirror. So these are the four axes which will the ray will be passes and molecule will start rotating. Okay, and by using this we can identify the point group, whether it will be CNH or it will be CNV or it will be DNH or it will be DNV. So here the subsidiary axis will be mainly for the D, for this D axis. Okay, and this N is means N will be 1, 2, 3, 4, 5, etc. like this. Okay, let us discuss in which axis there will be certain point groups are present. If there is a presence of the principal axis, then CNH will be there, and to be a CNH axis, there will be one of the horizontal plane, right? So horizontal plane will be there, and if there is a horizontal plane, there is no condition that there will be the vertical plane. There must be a vertical plane, or it may not. It may not. It may there or it may not there. But horizontal plane must be there for the H. So if there is a principal axis, if there is a horizontal plane, and it may there vertical plane or it not be there, then it is called as CNH, and there will be no subsidiary axis, because here there is a notation called C. If there is a notation called C, then there will be no subsidiary axis. If there is a notation called D, then there will be a presence of subsidiary axis. So we must tick right to these both, because there is a presence of subsidiary axis only for the D notation, not for the C notation. So this is the main trick you have to remember. Okay, and second will be the principal axis. Then here for every molecule, principal axis must be there, because to rotate the plane or to rotate the molecule, we have to get the principal axis. Okay, and now there is a vertical plane, and for every molecule there will be which have vertical plane, so they don't have horizontal plane. Okay, means if there is a horizontal plane, it may have vertical plane also, and it may not have. Okay, but if there is a vertical plane, there will be no horizontal plane. Remember, if there is a 10 molecules, all 10 will be the vertical plane, but there will be no, all 10 will be horizontal plane. You understanding that? Okay, so there will be vertical plane. Okay, for V it will be vertical, then there will be the H, right? So D and H, for this there will be the subsidiary axis, there will be the principal axis, and there will be the horizontal plane, and again it may have or it may not have for the vertical plane, and then there will be the vertical plane. For the vertical plane, horizontal plane is not there, and for vertical plane it have the vertical axis. So this is the simple trick. Okay, you are already remember, I think, this is because this is the most simple trick, and by this only you have to get the idea to solve the point group, and it is very easy to remember the point group or to identify the point group if we know these certain rules. Okay, let us see how this sigma h, how this sigma v subsidiary axis and this principal axis work on the molecule. Let us discuss the first one. Here the molecule will be CH2, Cl2 and F2. So here we have to see there that there is a chirality or not. So here for this carbon there is a one carbon is attached, in another there will be the fluorine and hydrogen. So this will be the chiral center, right? So this does not have any symmetric elements, and there is no point group, because for the point group we have to rotate it, right? So there will be the for any rotation it will do not get the same element in that place only. So that since it is a chiral carbon, these two are the chiral carbons, so this don't have any point group, but this have the reflection. See here F and here F, H, right? And here Cl and Cl, means this have the center of inversion, so this just have Ci, just this is have the Ci, but this does not have any point group. Okay. Let's come to H2O2. For the H2O2 we have here 2O and there will be H. And first we have to see that here if there is a principal axis, and for every molecule have the principal axis, so we have to set the molecule like that. This element again come to here only, so that let's see how it will become like this. When just we have to make like this, we pass the molecule like this, we pass the ray principal axis like this. Okay, here there will be two oxygens are like this, and when we pass the principal axis like this and we rotate it, then this hydrogen will be go upside and this hydrogen will become like this, hydrogen. Okay, and another, this is for the C1 and this is C2. Again we rotate and again we will pass like this and again we will rotate, and for the second rotation the molecule will be like this. So here it will again come to the its original structure. So this is the completion of our operation. So there will be two axis of the C, hence it will be C2 axis. Since if we cut like this, like this, since there will be no plane of the symmetry here, means if there is a, for example I took here H and H, if this hydrogen is on the below of the plane, if this hydrogen is on the below of the plane, then it will have the vertical plane of the symmetry, because it will cut like this, and also we can make like this, since there is a perpendicular axis of the symmetry. So there will be possible of the both horizontal and vertical, but here there is the opposite. There will be trans side of the hydrogens, so there will be no vertical and there will be no horizontal planes. Okay, hence it will only have C2 axis of symmetry, so the point group will be C2. Okay, now come to the H2O. This is H2O molecule, and hence we can see here there will be oxygen and hydrogen and hydrogen. After the rotation there will be like this, there will be rotation like this, hence after the rotation we will naming as H1 and H2. After the rotation H2, H1 and again H1 and H2, there is the rotation of the hydrogen will be take place by the like this. Since there will be C1 and C2, there will be two rotation is possible. For again after the two rotation there will be original position of the molecule will be arrived, so that we can name this as the C2 axis. And here there will be vertical plane. See here when we cut like this, if there is a, this is the oxygen and this is the hydrogen and this is the hydrogen, we will cut like this, okay, like this, so that there will be two hole, so that there will be vertical plane is present, right? Come to here, if there is a principal axis and if there is a no subsidiary axis and there is no horizontal plane, only there is a vertical plane, then this will be C and V, means here n v will be number of rotations, so it will be C to V. So oxygen, so water molecule will be C2V point group. And when we come to the NH3, this have the like this N, H, H and H. This is like this, like this. So here there will be one hydrogen, second hydrogen and third hydrogen. When we rotate, this hydrogen will become, this hydrogen will come here, one rotation, and this hydrogen will go here, second rotation, and after the third rotation, this hydrogen will again come to here. So there will be rotation like this, hence there will be C3 axis of symmetry. Okay, since this is the perpendicular, means here there will be three dimensional, means there will be n is here and one h will be here, one h will be here and another one h will be here, like this. Hence there will be axis is passing through here, so that there will be passes like here, and also there will be cutting off like this. Hence there will be no horizontal plane, but there is a vertical plane. You understand? Okay, if there is a principal axis is like this, if principal axis is like this and it is perpendicular to this, then there will be presence of horizontal plane. Understand? If there is a principal axis is like this and there will be the presence of like this, then there will be the horizontal plane, then there will be the subsidiary axis, but here there is no perpendicular to the that of the principal axis. Understand? If see here, this is horizontal plane. If there is a two elements like this, here H and here H, if I put like this, and there will be horizontal also, hence in that case there will be the H will be present and it will be C2H, but here there is no H and there is no perpendicular to that of the principal axis, then there is only vertical plane is present, and here it will be C3V, right? Okay. Come to this CS to Cl and fluorine F. Okay, let us draw this here, CH2 and Cl and F. Okay, C, and we will make H, F, H and Cl like this. Okay, if we made like this, then there will be the no possible of the rotation will be taking place, since there will be two heteroatom will be there and there will be two, this is a chiral molecule, understand? Sorry, this is the achiral molecule. Understand this, because there will be two hydrogen will be presenting. There is, since there will be presence of the point group here, and there will be no that such rotation, means it will be rotate, full rotation will be taking place, since it will be having C1H, means there is a like this, principal axis will be like this and there will be rotation, full rotation will be taking place, that this H will be, there will be H and this F will be again come to like this. After the one rotation, this fluorine will be come to its original position, same like chlorine and same for the hydrogen only. For this full rotation, hence there will be cutting off like this only. If we cut it like this elements will be present only in this here only, there will be no rotation, means if we cut it like this Cl will be cutted to two halves and this C and H and F, because they are on the plane only, hence this will be cutted, hence there will be horizontal plane will be present. So this is the C1H is the point group. Okay, And next will be the, so here means here this, okay, here this molecule, this is here, this is, you are getting that like this only. How the C1H is there, when we put it like this, and there will be rotation will be there, hence this is C1H. For C16 and H10, there will be like this, there is the presence of the H10 and C16. So here there will be, see here, there will be rotation like this. If we rotate like this, then these below H will go upside, and this upside H will be go downside, like this. Also like this. If we rotate like this, then these will become here, and these will be go here, like that. You know. So this is how it will be goes. So there will be two axes. There will be like the one rotation, and there will be second rotation. Means first rotation will be like this. This come will here. This is C1. After rotation, this H will come here. So it will be original position. I shown in the upside only. Here there will be A. After first rotation, it will be A will be, this A will be go here. It will be C1. And after that again we will rotate, again this A will come here, so it will be C2. So there will be two rotations, and there will be the horizontal plane. Here we are getting that like this. If we consider this as the principal axis, then this will be the perpendicular to this. Here see, there will be 90 degree. You are getting this, so that I took this molecule. This will be easily, you can get that how the perpendicular, how will be horizontal plane will be there. And if we took this as the principal axis, then this will be the perpendicular to for that. Here we can easily get the perpendicular line. So this will be the, there will be two rotation, and there will be the perpendicular axis, hence this will be C2H. Here see here, and there will be vertical plane also. Here if we cut like this, there will be the vertical plane also. So vertical plane will also present. There will be the presence of the horizontal plane. There is no presence of the subsidiary axis, and there is a presence of the principal axis also. Then there will be the presence of principal axis, presence of horizontal plane, and presence of the vertical mirror. So that there will be CNH will be there. Hence CNH means C2H. Okay. Next will be BOH3. Okay, here the presence of like this, and here the rotation will be taking like this. If we rotate like this, first here it will come to here for the C1, again it will go to here for C2. Okay, and again here it will go to here for C3, and again when it will go to here, it will be in the original position, and it will be the complete operation will be took place. So it will be C1, C2 and C3. So there will be three rotation will be there, so it will be C3. Okay, let know the this is having the horizontal plane and vertical plane is there or not. Okay, let cut this molecule. So the molecule will be like this, the principal axis will be like this, and if we pass this, and the vertical plane is also like this only. Okay, when we pass like this, there will be the horizontal plane will be present like this only. Here this is like here, this is like this, but here this is like this, same like this here. So this is the C3H. Okay, like this only. It is very simple. There is will be very simple. Okay, now this is called as alene C3H4. Okay, and here there will be presence like this. This is there will be presence, and there will be rotation will be taking place like this. This HA will come here. Okay, and this HA will always again will go to here. Okay, and there will be presence of this also here. There will be rotation like this. Then this will be goes here, and this will be come here. You understand? When there is a rotation will be taking place, this will goes here and this will come here. And when will be there rotation, there will be this will be go here and this will be go. Hence there will be two principal axes here. We are getting one will be like this. After the rotation like this H will be go here and this H will be come here. So there will be C2. Like okay, and when we pass like this, okay, we are getting when we pass it like this. Okay, not there, like this. This H will come here and this H will be go here. After here it will become here and it will go here. After that this will again come to here and it will go here. So that again another C2 is there. But for this time we will not make this as C2, but we will name this as D. So overall this is called the subsidiary axis. This is called subsidiary axis. Okay, so that there will be presence of subsidiary axis, and there will be also there is presence of vertical plane also. Okay, there is the presence of vertical plane and there is the presence of subsidiary axis. Hence here there is a presence of principal axis, there is a presence of subsidiary axis, and there is no presence of horizontal plane. Okay, there is no presence of horizontal plane and there is a presence of vertical plane. Hence this will be DNV. So this will be DNV. In the place of N we will put this 2. Hence it will be D2V. When we write this D, hence we will present this V also. We can write D2D also, or we can write D2B also D2D also. In the examination they may give both D2V and also D2D. Both are same. Okay, both are same. If only D2H are different from these both. This is horizontal plane, these both are vertical plane only. Okay, come to here. Now come to this. There will be difference will be there. C2H4. Okay, here there will be this. There will be rotation like this. Okay, and there will be rotation like this, and there will be rotation like this. There will be two planes are here, and one we can consider as the principal and one we can consider as the subsidiary. So there will be D term will be there, and again there will be 1 and 2. So there will be 2 D to 2. Hence there will be this is the perpendicular to the that of the principal axis. If we consider this as the principal axis, then this is the perpendicular to the that of the principal axis. And if we come to this, if we consider this as the principal axis and this is the perpendicular to that of the principal axis, right? Also we can turn like this also, and also like this, right? So this is the H, D2H. You are getting, and this is the here there will be cutting of the molecule will be take place. Hence there will be vertical plane is also there. Okay, and also when we come to C2H6, then there will be like this. This C2 axis has the special character like this have the vertical plane also, and it have also horizontal plane also. Means when we cut it like this, means this molecule has like this. For this carbon it will turn like this, and for this here we will get it simply here. When we pass through here this line, these three will be like this, and this will goes to 1, 2 and 3. These three, this H will be go here, this H will become go here, and this H will be go here. Just assume that this is the NH3 molecule. If we assume this as the NH3 molecule, there is the two NH3 molecule are attached together to form C2H6. Like that only, same like that only. Okay, so that this will be having the has 3, right? There will be 3 operations are required to make the original position. Okay, means there will be 3 operations are took place, and there will be 2, means there will be like this. One will be this and another will be this, right? So there will be 2 axes of the rotation. One will be principal and one will be the subsidiary axis. So it will be named as the D, right? And for this here it will be D3D, and here it will be D3H. Now come to S8. Here there will be, this is how this structure is like. Here there will be sulfur is there, and other sulfur is back of this, like here also back of this. This sulfur is front, and this back there, these are 2 sulfurs are there, and again this sulfur are the on the front only. You can getting this sulfur is on the front side, and again these 2 are the on the back side, and this is front side. This is front, this is back, this is front, this is back, this is back, this is back side, and this is front side. Like this arrangement is there for the S8. Okay, for this arrangement it will be, there will be no horizontal plane will be possible, because when we there here, and we will rotate like this, like the benzene. You know the benzene, like the benzene. When we there here, means for one rotation will be there, 2, 3, 4, 5, 6, like this. There will be 8. There will be S8. For this S8, there will be 8 rotation are the possible. 1, 2, 3, 4, 5, 6, 7, 8. Like this, 8 rotation is possible. So this will be goes like, for this there will be 1, 2, 3, 4, 5, 6, 7, 8. Same like the benzene only. This will having the 8 rotation is possible, but this does not have the, means if there is a rotation of the 8, and there will be operation will be 4. For the 8 rotations there will be 4 operations, like D4. Okay, and there will be no horizontal symmetry, because it will be these 2 are the front and these are the back. So it will be no passing through the perpendicular, but it is a parallel. So there will be vertical plane is there. So this will be D4D will be there. When it will come to ferrocene, there are 2 types of ferrocene. One will be eclipsed and one will be staggered. Okay, you will clearly know the difference, that how the eclipsed ferrocene and how the staggered ferrocene will be there. I will give to the GIF image and the 3D rotation, 3D representation, how this eclipsed ferrocene is differ from that of the staggered ferrocene. So here we will I will took the point group, and I will explain this, and I will give the GIF image, so you can clearly know that one ferrocene will be always parallel like this. means not like this. One second. For this one will be like here in the F and here like this, like this. These are the parallel sides. So here there will be Fe. So when we look like this will look like there will be only one molecules, one atoms are there. So it can easily make the horizontal plane when the when Fe is like this, Fe, and here it will be like this. Here one will be there and another will be like this. Here there will be no similarity, means this will be rotated like this. So here there will be, when this is same like this only, but this Fe here there will be like this, here like this. So there will be no symmetry like this. There will be pointed towards upside and there will be symmetry like this, understand? But there is no symmetry like this. This is the main difference here. Here both are the opposite and here the points are towards only one side, but here it is on the opposite side. These points are on the opposite side like this. Here the pointing is opposite side. Here F is there. Here there is a pointing in similar side like this, similar side. Due to pointing in the similar side, there will be no horizontal plane is present. Understand this? Since there is a cutting off like this, so this will be d phi d and this will be d phi h. Okay. Next come to here this PdCl4. Here PdCl4 like this only. Here there will be like this, rotation will be there. There will be principal axis and here it will go for here first one rotation, 2, 3, 4. After the 4 rotation it will come to here. So there will be here it will be d4 and also there will be if there is this is hence there will be presence of here C2 axis. There will be rotation will be there like this, and if there will be like this only, this will be goes like this. So there will be C2 axis is there. So this is called subsidiary axis. So there will be horizontal plane. So therefore d4h. Next d5h, and this is for the benzene. Already I took this 1, 2, 3, 4, 5, 6. So this is will be 6, hence this will be d6h, or you can take as c6h also. And these are the molecules which are the forming the special type of the molecule like H2. This H2 have the d infinity h, because this will having this also plane, this is perpendicular to this, hence there will be the subsidiary axis will be there. For the C2 is there, hence there will be infinity rotation will be taking place. So there will be infinity rotation. So this will having the, when there is a similar atoms are there like H2, O2 like that, then for H2, O2, N2 it will always have the d infinity h. Okay. And this will be C60 Br24. Okay, this will be, I will give the 3D structure in the video only, and you can identify this. And this will be having the TD like only, means TH. This having TH. Okay. This here there will be methane molecule. There will be H, H, H and H like this. Like hence there will be tetrahedral, and here like this one. Here these are the on the plane. These 4 fluorine or for this sulfur, there will be 1 fluorine, second fluorine, and here third, and here fourth. So in the plane there are 4 fluorines are there, and there is the upside one fluorine, and below there is another fluorine. This is called the octahedral geometry, and this is the C60. This is the huge molecule. You studied this C60, hence it will be IH. Okay, I will this 3D elevation, so that thank you once again, and thank you one and all.